the recording. So this is, you guys got a bonus that isn't going to be in the record for people who watch later. Basically, though, the idea is we opened up a file. We stripped off the file name so that we didn't have extra spaces either before or after that would mess up opening the file. We opened it up in read mode. We opened up another file that has smaller.txt appended to the name as a write file. We walk through every line in the file, splitting it based on the pipe, stripping out each one of the fields, and then we put together another string that represents that data without the excess spaces, and then close both of the files. So if we come down here now, I can put in imdb data.txt and hit oops. Excellent. So when we try this, we actually get an error. And if you remember, this is something that you guys had in the assignment, and it's encoding equals, I think UTF-8 should work, maybe. Let's see if that works. That may work. I may have to look that one up. Okay. This encoding, the default encoding is Ascii, right? And most of you should be familiar with Ascii. The problem is that in the IMDb data, and I don't know if it's here in this one or not, there are some foreign names, and foreign names sometimes have non-Ascii characters. Like, I'm gonna go through all of this and pull out one. Like circumflex, or accent aigu, or grave. So this line basically says, don't limit yourself to Ascii. There's the possibility that there are non-Ascii characters. So if you're getting this issue, Unicode decode error, you just have to pick something else. And in this case, UTF-8 is enough to allow this to go. And I think we can actually open this file up. Maybe. We'll see if this works or not. But the idea is that now we've translated this into a file with less wasted space. Any questions on that? Let me see what questions we have in the window. If you have 4-line and open file name, so actually that will automatically close when the loop ends. So that will close the file associated with file name at the end of the when you exit the scope of the loop, that will close the file. You should be all set. There we go. So, there's all the data. Again, with the blanks. Do we need to know these special encodings, or can we look them up? You can look them. Certainly the one we gave you for lecture 15. Right, so the one we gave you for lecture 15 will work for any of the data you have here. That's not the UTF-8, but it is an equivalent encoding. It will let you open these files. This is not something that I would be too worried about unless you're trying to test and debug your code. In which case this may be necessary depending on what data we give you. The test is not open everything, but it is open notes, open book, and you can use the class notes. You can use the Spider IDE. You can use Python. You're not allowed to use Discord. You're not allowed to talk to your friends. You're not allowed to use Google to look up answers. You're not allowed to use Stack Overflow. But any of the resources that we provided you, any of the course website where the lectures are is fine. Don't be posting things to the discussion forum. But yeah, other than that, it's it's a relatively open book. You can look at generic Python documentation, but remember that most of the functions you need are going to have a help file associated with them. So you can come in here and say something like help list, and it'll give you all the data you need. So you shouldn't have to do that. Submiti does not post a manual timer. If you submit your code, it will tell you when you submitted. So I think if you submit the first time, it should allow you to. Well, there's no way for me to test since I submitted a long time ago. But if you come in, yes, there is. So if you come into the practice test, let me see if this does what I think it does.
We are looking at Spider.
Okay. I'll move over in just a second. Okay, so I just came into the practice test. I had to come in as myself as a student. So now I have something in there. I think if I hit submit, and go down to the bottom, well, apparently I first accessed this on October 27th. I don't know whether this shows up before you've run over the time, but I think it does. So if you do a submit right away, or a submit after you've put in your first thing, you should be able to see your first access. We can't have a pop-up timer. Submiti doesn't support that. We asked. They are working on it. They've had synchronization problems, and they don't want to give you. They figure no data is better than bad data. So you will have to use an external timer. But I think you can at least get your time of first submission out of here. So 100 minutes over means you get a 0 on the test. So be careful. Submit within the time limit. And also we're putting on, we're asking you not to submit more than 10 times. After 10 times, we will also start imposing a penalty. And the reason we have to do that is because there are a lot of you, and we can't, if everybody submits 50 times, I think we will bring Submiti down. So we will begin imposing a penalty after 10. Okay?
So beyond that first submission, we just have to be very accurate about our own self-timing.
Very accurate is a subjective call. You have to be accurate.
I know that's the best description I could have used.
Yeah, so you don't want to go over. I'd probably give myself 88 minutes, and then, time should stop when you hit submit, or at least the time tag should be taken when you hit submit. If you're close to the 8:59, or the 59 minute mark, and you hit submit, and it takes a while for Submiti to return back to you, that should be okay. The time tag should be the time you hit submit the first time. So, or the time you hit submit, not necessarily the time that the screen refreshes. Okay. Why is strip next to the input? Because the input command returns so the input command returns a string, right? So this call returns a string, and I want to avoid, so without that, if we run this, right? And I put in something like space, 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 Hanks, that text, right? Those extra spaces don't look important to you or I, but the computer takes them as part of the file name. So I did the strip to take that out. I like putting the strip here when I'm not working on Submiti. Right now, you're submitting your test to Submiti, but we're not having the same requirement on you of reading the input, printing the input, and then processing the input. You're allowed to do it all in one fell swoop. So when I do that, I like to do the strip here, just because it saves me a line of text, and it is just as effective. Okay, so now we can say space, 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 Hanks.text, and it comes back. You know, it opens the file and everything works good. Fields equals line.strip.split. Yes, you could. There are always multiple ways of doing it. I think that would work as well. So the question is, you know, can you do well, actually, so this had, can you do this? Line.strip.split. And you can do that. That won't remove extra spaces from the file name, right? Because we've already opened the file name. The file name's nowhere's in there, right? So it doesn't actually help us with the file name. And it actually doesn't help us here either. So let's do this for a second. Let's look at what that actually does for us. If we run this and we do hanks.text, sorry, line.strip.split. We don't need the function call. Right, if you do this, and now we look at hanks.text.smaller, notice that we just created this. It's 305. Oh. I assume that we wanted to pull this out too. Maybe not. That'll be better. Okay, now let's go back and look at this. Okay, what you'll notice is that that strip only takes stuff off the back end, the back and the front end. So things that were embedded in the middle, and particularly these new blank character lines that were between the end of this field and the pipe, aren't touched by the strip. So, you know, depending on what you do, that's certainly not an invalid line, but it doesn't save you from having to still having to strip here as well. Okay. So I am going to tell you that Submiti is absolute. It does you know, get it in by the 90 minutes. It does start counting, but it accumulates. You know, if you get a 99, that's one thing. If you get a 72, because we took off 28 minutes, that's another thing. So, you know, please try to be on time. We may, you know, we can always adjust that if we decide to, but Submiti will tell you have points off as soon as you've gone past the 90-minute or the 135-minute or the 180-minute. In the practice exam, there was a question that said to tell what the closest points are in a list of tuples. Would I mind going over that? Sure. Let me just talk a little bit about general test taking, and in particular some recommendations for this test. So, and maybe I'll grab that while I'm at it. So one of the things that I want you guys to be careful of is, this is a test. It's not a homework assignment. So we want you will do best if you get everything exactly right. But it's far better to answer all the questions imperfectly than it is to agonize over some subtle details and end up only getting to 1 or 2 or 3 or however n minus x for some of the questions, right? So don't leave questions blank. What I'm going to recommend you do, just like with the practice test, there's going to be a screen that pops up with the rules. Read through that, get yourself in a test-taking mindset. Your timer doesn't start until you hit accept on that button, right? Once you've hit accept, then you'll go to the main test. Your timer will start. Read through the questions so you can start thinking about every question. You don't have to start writing immediately. Read through the questions. I actually like to, on the first pop-up screen with the rules, I'll read through the rules. I'll do a few deep breathing exercises. I'll click on accept. I'll read through the questions. I'll do a few deep breathing exercises just to get myself calm. You want to know what the questions are so you're not surprised. When you come to one and you say, oh, geez, I have no idea how to do that, and then you panic every time you come to a new question. Read all the questions at once. That way you can start thinking about them. You're not going to be surprised. Go through and do all of the questions. Fill in something for all the questions, or at least all the questions you have an idea for. Get the algorithms as close as you can. Don't try to debug them at the first cut through. Just get them working correctly. Once you have something in every question you want to answer, then go back and try to pick up all the small points on formatting or the subtleties. So get something there that's the major part of the algorithm, something that demonstrates competency of the material, even if it doesn't run, even if there are small errors in formatting or in exactly matching the output. Get that done first. That'll get you, pretty far along in the number of points. Then you can go back, and only after you have that done, from there on you can work right up until the end of the test on getting, debugging your code, making sure your code works, making sure you have all the subtleties. One other thing to keep in mind, as you get close to the end of the test, make sure you do a submission before the end of the test. But you can always come in, as long as you have a submission, you can always come in here. And of course, I only have one submission. Here, let me make that's because okay, I can make another submission though. We'll do this, we'll make another submission.
We see Spider right now.
You see Spider again. That's okay. Okay. Let me, for some reason, I lost my, my auto checking, my auto changing. Okay, so, nope, that's not it either. We'll go here. Okay, so now I made another submission. So you can come down here and you can see that every time you make a submission, you get this bar increases by 1. As you get close to the end of the time, make a submission. And then you can come in here after you're done and you see that you lost a whole bunch of points because you were late. You can come in here and you can select a previous version, right? That'll take you back to the previous version. Now, unfortunately, this was late for me as well. But once you get to this previous version, just click that grade this version, and that'll move it back to something that was on time. Okay, so use the submittee tools. You've got 10 submissions before we take any points off. As you get close to the time, as you start fixing problems, start submitting. And then when it comes down to you're over the time limit and you're getting points deducted here, go up and select an on-time submission or a submission that's almost on time as the one you want to have graded. And, and choose to grade it here. Okay, so that's a way to kind of get around the fact that there's no. Any other questions? Let's see. I got questions on.
Is there going to be any auto grading on the exam?
Not that you're going to be able to see. We haven't decided whether we're going to provide it to the TAs or not. Last test. Last test we after the test we went in and enabled auto grading, so the TAs could at least see, identify where there were errors, to make it easier for them to go through and figure out whether code constructs work the way you thought they did or not. But we haven't decided whether we're going to do that. It won't be something that you'll be able to see. The only auto grading you'll be able to see is down here on the minus, the deductions for time and deductions for too many submissions.
So we'll have like 100 out of 100 if we have checked time limit. I mean, negative 100 out of negative 100 for the time limit.
I am just way over the time. I started.
Oh.
This is 2 days ago.
Okay, so it should say 0.
Yeah, so it should say 0
100.
out of minus 100
if we're not late.
Yeah.
Okay.
Okay, so
just making sure.
Yeah, I just I started this. Well, apparently I didn't realize I had ghosted in as myself, but apparently I had. So yeah, so I can't show you a non-overtime one because mine's already 2 days late. I lost 2,905 points.
Professor Turner,
Yes.
the person who was providing the review session yesterday said something along the lines of it's better to write pseudocode if you don't know how to code it in Python than to just leave it blank. Is that true?
That is true.
Okay, but like she said, you would at least get 5 points from doing that. How many points could you get from actually putting in pseudocode?
So that depends on the question. It depends how many points the question is worth. We like to for something reasonable, we like to give credit for effort. So there's generally a lower bound to how many points we'll take off for anything that's reasonable. So pseudocode would often be considered something that's reasonable. Generally it's maybe 10% or something like that. So on or maybe 20%. So on a 20-point problem, 4 to 5 points might be obtainable, not for anything that works, but just showing demonstrating that some understanding. Okay. But it's really depends upon the problem, and how much the problem's worth, and how many parts there are, and things like that. Okay. But yeah, don't leave it blank. There's always you don't get any points for blank. The TAs and the mentors and myself, we all love the blank ones because, we prefer perfect answers because perfect answers are also very easy to grade, but blank answers are much easier to grade than non-blank wrong answers. Wrong answers are tough to grade because we try to give you as many points as possible.
But do you know, like, if there's any place we can find comparable practice problems to, like, the difficulty of the exam?
Sure. Well, the APO should have back copies. We don't release our back copies of the exams, but these, the study guide, the overview document, those are all either problems we've considered for test problems or problems that have been on the tests before. So, it's particularly if you go for the long form questions, or you go for the long form questions on the sample exam we gave you from the spring 2017. Those are all very close to possible problems. Okay, any more? Yeah, so to avoid you dealing with closing the file, you can put all of your file-related code in a with. Yes, I'm not a big fan of withs, just because I like to explicitly see what's going on.
I have a question.
Sure, go ahead.
So I took the practice thing just now. They didn't have like a timer at the top. Will I have a timer on the actual
No,
thing, or will I have to set up
Submiti doesn't support that. They've tried to put it in. It's an open item, an open issue. They just
so I'll
haven't been able to.
have my-
Yeah, it's the problem is if the synchronization gets off, then we could be telling you have 15 more minutes and you have no minutes. So they're really concerned about giving you bad information. They want to make sure that it's very reliable. So we don't
Well,
have. Go ahead.
sorry. Will the exam2 that we're getting be as easy as the exam2 practice test?
The Exam2 practice test on Submiti, that
Yeah.
was solely to expose you to the interface you're going to be using. So that I can guarantee that your test will be harder.
Wait, how many questions will we have then?
You'll have 3 or 4.
Okay.
Okay. Python tutor is allowed. Python tutor is allowed. Don't worry about that. But again, it has to be your own code, and don't be sharing your code, because Python tutor, don't be inviting other people into your Python tutor session or sharing code that way. We will be running the plagiarism software. There was a question.
I have a question.
Sure.
About like the resources we can use. Is it like an issue if like we Google just something as simple as .find just to make sure we're using it right?
So if you want to do a .find, right? Right. So there's help available in Python for all of those things. It's built right into Python. You don't need to do that.
Okay, thank you.
You're welcome. So
what
there was
if we want to,
Go ahead.
what if we wanted to, like, for example, look for a concrete example of how, like, let's say .find is used? Is that like acceptable to use Google for that, or is that not allowed?
So we you can use Google, or you can just use your notes, because we have all that in there. I would prefer that you stay away from using Google, because it's too easy to end up on Stack Overflow and get an answer.
Okay, all right, thank you.
Okay, so okay, so there was a question about find closest points, and the question. Let me see, what was the question in the practice? The practice test was write a short program to print out the 2 closest points in a list L of tuples. You can assume L is given. Okay, yeah, let's do it right here. So I'm just going to pop the L in there. We're going to assume L is given. If I say assume L is given, you don't actually have to write it in here, because you can assume L is given. But of course, your code won't run if you don't, because you won't have an L. Okay, now when you think about the closest points, and we can put in, we'll just leave it like this for now.
We can see you typing.
You can't see me typing because the stupid auto change is still not working. Okay, let me go back and put that on. Not put that on, but let's go into everything. Okay, so there's the L. So let's think about this. We had this before, right? We talked about closest points in one of the exercises, and we said there's a couple things you have to be careful of with closest points. What we want to do is we want to walk through this list, looking at every tuple, and comparing it to every tuple, to every other tuple in the list. And what we talked about was, the fact that, well, we want to be careful not to not to compute the distance between an item and itself, because that's always going to be 0, and that's always going to be the best you can get. And we also talked about this being symmetrical. So in this particular case, and you have to be very careful about the problem you're choosing. But in this particular case, since this is symmetrical, and since we don't have to go back in the other direction, right? 0, 0 is the same distance from 0, 1 as 0, 1 is from 0, 0. We can take some shortcuts here. So let's start off we know we're going to need a for loop. So let's start off by typing for L and L. This will be our outer loop. This is going to go through, and it's going to compare each one of these to well, it's gonna cycle through each one of these tuples in the list. So now we know how we are going to get through each one of these values, and now we have to figure out how to compare each one of these values with everybody else in the list. Here's where it gets a little tricky. We could do for let me show you two ways. We'll do for L1 in L, and we'll do for L2 in L. And if we do this, let's just throw in some code to print some stuff out. We'll say print distance of and we'll just do this. Okay, so we're going to print out our distances, and now we have to put in format L1, L2, and then now we're going to have to figure out a distance. So let's calculate the distance here. Well, the distance between 2 points is the first item in each one. So L1 sub 0 minus L2 sub 0 quantity squared plus, well, the same thing for the second element in those tuples. Control V, L1 sub 1 minus L2 sub 1 quantity squared. And then we need the square root of this. And if we wanted, we could do an import math. Let's do that. So we'll move this line down. We'll do an import math. And we'll do math dot square root. Right? So that's getting us the distance. And so now we're going to just go through all of those. We're going to form all possible pairs, and we'll print out the distance. And this isn't really a complete solution, but it's something that I kind of want to test out for you guys. On your test, complete the solution first so you don't get stuck. But on this one, we'll just run that, and we'll say run it. Right, and here's what I wanted to show you. Right, comparing an item to itself gives us a distance of 0. So when we come through here, 0 is always going to be the smallest distance. And with the solution we have, this is going to be a pain. And then if we look at something like 9,5 to 0 and 0 to 9,5, right, that's symmetrical. So we only have to do this in one direction. And again, same thing with our best answer, 0, 0 to 0, 1, and 0, 0 to 0, 1. Well, again, that's symmetrical. So, 0, 1 to 0, 0. So we don't have to do that in both directions either. So let's go back. And based on what we learned, let's change this just a little bit. I guess we can just come in here and say if L1 not equal to L2. Right, so that's just going to say if we're doing the same one, it won't solve the, yep.
Sorry, you're on Spider.
Got it. Right, so it won't solve doing the duplicate effort, but quite honestly, this is a test. We're not asking you to be efficient. We're asking you to give us an answer. So, quite honestly, we're not asking you to avoid symmetry. If I did say, avoid the symmetric case, then you would have to be a little bit more diligent. But if we do this, this is probably going to give us what we want. It'll avoid all of the issues, and it'll only print out right? It'll only print out when L1 and L2 aren't equal, right? So you see that now we still haven't gotten rid of the symmetry, but the zeros are gone. So now we know that what we're calculating is going to give us the minimum distance. We can come back in here, and now we can just kind of manage that. We can say closest equals and I like to seed this with a real value, especially when we're going to be walking down potentially. So we want to take L0, which is the first.
You're in Spider again.
I am in Spider yet again. This is going to kill me. Okay. So I took and I pasted this line in, right? I took closest and I set it equal to be math square root L0, 0, L1, 0. So what I'm doing is I'm taking these first two tuples out of L, and I'm calculating the distance for them. So we actually get a valid distance. The other way you could do this is you could just find an impossibly large distance, but then you have to worry about us testing with impossibly large distances, and your stuff may not work. So that's the closest distance we find cannot be any closer than that. The closest distance has to be no farther away than this, and then we can say I1 equals 0 and I2 equals 1. And what these are going to be the indices of the closest match, right? So now we've decided, without making any checks whatsoever, that we're going to match I1 and I0. This first and this second. So our first tuple is going to be 0, 0, and our second tuple is going to be 0, 1. This is just arbitrary. We're going to be able to change this during the loop, but we're just guessing that the first match is going to be the best. And now when we come down here, we can say if L1 is not equal to L2, nope, that's not going to work. We'll set this to the actual tuple instead of the index of the tuple. So this will actually work. All right. Okay, so now I1 is this first tuple, I2 is this second tuple, and this is the distance between them. Okay, so now we can say if L1 not equal to L2, in other words, we're not comparing 0, 0 to 0, 0, and distance is less than closest. Right now we found a better match. Then we just reset all of our variables. We come down here, we say closest equals distance, dist, and I1 equals L1, I2 equals L2. And then, now we've walked through, we've avoided the trap of comparing an item against itself. And at the end of this loop, we should have I1 and I2 should have the valid values. So we can come in here, we can just do print closest colon comma I1 comma and I2. Okay, and that should be the solution. And if we do a Control C and pop back over, right, Control A, Control Control A, Control V. Come on. Is this the right solution? Yeah. Okay, and we should be able to run this, and this should work, except it gives us closest.
You have I1
You wrote
twice in the
I1 and
previous in the
I1
print.
twice.
I wrote I1 twice. Boy, that would be worth 2 points off. Thank you. Okay, so that actually works. So that's one way of doing it. There are multiple ways of doing it. Are there other questions, or should I go through another one? Yes, the exam would be better in person. Donna Noda has an excellent comment. You know, you really do have to think about this like any other skill. You got to practice it. It's not going to come easily to you at first. I've been doing this since 1985. If you want to count after I had a degree, you go back another 10 years. So, you know, this is, you know, you will get better. That's why we try not to put too much stress on you guys right now. Any other questions, or should I go on and give you another way? So there's a question that says, can I tell you if there's a problem, the complexity of homework 5 will be on the exam? Homework 5 was... So certainly there could be a component, right? Since you've already had homework 5, you can study off it. So there could be a component that asks you to do something similar to one of the pieces of homework 5. The entirety of homework 5, we expected to take you between, well, take all of the homeworks. The shortest homeworks are geared towards about 6 to 8 hours. The harder homeworks are geared for, you know, should take you a little more than, or should take you more than that. You know, and I know some of you invested a lot more time than that. Practicing is part of the game here. So don't feel bad if it took you more than that. For me, doing the homework still takes me a couple of hours. So no, we wouldn't have something in aggregate as complicated as homework 5. But picking out any single part of homework 5 and asking you to do complicated logic is certainly doable, particularly since you've already seen that. Okay. All right, let's take a look at another answer to this one. We'll start off with L again. And this time we're going to...
Professor, some people in the chat want you to go over truth tables.
Truth tables. Okay. Since I've given you one solution to this, and there's another solution in the notes that use indices. That's what I was going to go over indices with you. But the solution for indices is there. What in particular do you want to know about truth tables? Is there anything specific? Yeah, by the way, the prohibition against stack overflow is a prohibition against Chegg as well, just so you know. Okay, let me see if I can find a question on truth table. Well, okay, let's go over De Morgan's rules. I don't think I did that very well in class, or we had time for that. So let's look at De Morgan's rules, and we'll talk through that on. See if I can find that. And of course, that didn't switch. Let's see. De Morgan's rules were probably controlling loops. Decisions part 2. There we go. So this is in lecture 11. So let's look at one of De Morgan's laws. So let me write this down so I get it right. Okay, so if we look at De Morgan's laws, the first De Morgan's law is not EX1 and not times the quantity of EX1 and EX2 equals not EX1 or not EX2. So let's kind of walk through that in the next 10 or 12 minutes, and we'll give you a solution, or we'll show that using truth tables. So our goal in this particular part of the exercise is to demonstrate using truth tables that this is actually a true statement. So I'm turning on my handy dandy camera. And if you notice, when it comes on, we have some stuff in there. Somebody was asking me a question about Sudoku today. Let's turn off Spider. We don't need that right now. Maybe not ever. All right. So the law we want to look at is we want to look at not EX1 and EX2 equals not EX1 or not EX2. Okay, I ran out of room. Okay, so if we want to prove this using truth tables, we have two variables, EX1 and EX2. Okay, so what we need to do is we need to generate all possible values of EX1 and EX2. So the way to do that is you go true, false. Well, we'll go the other way. True, true, false, false. Okay, and this is for two variables. There are only 4 possible combinations. And then here we do true, false, true, false. Now if we have 3 variables, right, let's say EX0, we would do 4 trues in a row. And then 4 falses in a row. And then we would repeat this pattern again, and we would repeat this pattern again. And that would give you all possible combinations. Okay, but we only have 2 variables. So we're just going to stick with EX1 and EX2. We do have other clauses, though. So in the end, we want to compute this clause. So not EX1 and EX2. And we want to compute this clause, not EX1 or not EX2. And we want to show that these columns are identical. Okay, so if these columns are identical based on the input of EX1 and EX2, then this statement is true. Okay, so we've got EX1 and EX2. We have to do EX1 and EX2. We have to do, okay, so that gives us this column, right? Then all we have to do is negate that to get this column. And then we also have to do not EX1, this clause, and not EX2, this clause. Okay, so let's start filling in the columns. So EX1 and EX2, true and true is true. True and false is false. False and true is false. And false is false. Okay, so that gives us EX1 and EX2. Not EX1 and EX2 is the opposite. So wherever we have a true, we write a false, right? We take this column, and wherever we have a true, we write a false. And wherever we have a false, we write a true. So now we've filled out, essentially, we've calculated this side of De Morgan's laws. So now we have not EX1. Well, all we do is we take the EX1 column, and wherever there's a true, we write a false. And wherever there's a false, we write a true. So it'd be false, false, true, true. Not EX2, we do the same thing. We look at the EX2 column here, and wherever there's a true, we put a false. And wherever there's a false, we put a true. So false, true, false, true. Okay. And now, right, this is this clause. This is this clause. So what we want to do is we want to look at these two columns, and if either one of these is true, we put a true. If they're both false, we put a false. So we start off with false or false is false. False or true is true. False or true is true. True or true is true. Okay? These columns are identical, right? So because these two columns are identical, that means that De Morgan's laws actually hold. Is that what you wanted? Is that what the question was?
Could you go over that second solution that you were talking about?
For the closest point?
Yeah, for the closest point.
Sure.
Thank you.
You need to understand the concept of truth tables and how to get between different states. At least that's, you know, what's in the material here is should help, you know, should be something you can actually do. All right, let's go back over, and this time I'm going to remember without being told to pop over to this. Let's see. There we go. Okay, so let's look at another solution to this. We'll start out the same way. I'm just going to put a row of comment characters. We'll start out the same way. And this time we're going to use indices instead of values through the list. We're going to start out the same way, and this time I'm actually going to do I0 equals 0, or I guess I have I1. I1 equals 0. So this is the index, and I2 equals 0. And this time we're going to avoid the symmetry issue too. So we're not going to calculate 0, 0 compared to 1, 0 and 1, 0 compared to 0, or 0, 0 compared to 0, 1 and 0, 1 compared to 0, 0. We're only going to go through and do the ones that are unique. Okay, so we still need to walk through. So we can say for counter, oh, well, what the heck, I'll use I. I hate using I and J. We'll use I and J. For I in range. And we want to walk, I is going to be the index of our first variable. So we want to actually walk it over this entire list. So we want it to start at 0, and we want to go 0, 1, and 2. Well, 3 is the length of L. We want it to go to the length of L minus 1. So the range we give it is the length of the list we want to walk over, right? And this will generate indices 0, 1, and 2 into I. So that'll allow us to index and see every tuple by using, L sub I. So that'll be our first tuple. Okay, now what we have to do is we don't care about comparing, if I is 0, we don't care about comparing to the 0th element. So we can get rid of that. And if L is 1, we don't care about comparing to the first element, the index 1 element. We can get rid of that as well. So all we have to do is, and this could be, a much longer list. Right? It could be as long as we want it to be. But the key is that anything, so 0, 0 is going to compare against 0, 1 and against 9, 5. 0, 1, 0, 0 is going to compare against 0, 1 and 9, 5. 0, 1 doesn't have to compare against 0, 0 because that's already been calculated. It doesn't want to calculate against 0, 1, so it just has to compare against 9, 5. And if we put out another 10, 2, minus 4, 3, right? And in general, what we should realize is that as we move I through the indices of this list, J only has to be, the inner loop only has to walk through things that are to the right of I. So if we just want to walk through things that are to the right of I, we can write our for loop a little differently, right? We're going to make J move over a range, but now we can specify the starting point of the range, and we'll specify the starting point of the range as starting at I plus 1. So when I is 0, pointing to this element, we want to start at 1 and walk down the list, right? So we want to look at 0, 1, 9, 5, 10, 2, minus 4, 3. We want to walk all the way to the end of the list. So again, that's length L, right? So this right bound stays the same, but we can use the ability of the range to allow us to move the starting point of I up 1. And now we can come in here and we can calculate our distance function. And we'll put that into a variable dist, I guess. And now this time we don't have to worry about this comparison, right? Because we can never reach this case. J can never be equal to I because it starts at I plus 1 and walks to the end of the list. So we don't even have to worry about this I not equal to J clause. It's already taken care of. So all we have to say is if dist is less than closest, then we want to say closest equals dist. And I'm sorry, this should be I2 equals 1, not I2 equals 0. Closest equals dist, I1 equals I, and I2 equals J. Because we've just compared, and let's change this a little bit. This should be L sub I 0, L sub I, right? Because we're looking at the ith right? We're looking at the ith element, the 0th component, versus the jth element, the 0th component, and the ith element, the first component, and the jth element, the first component. Okay, so now this line calculates the distance between here, and then here, and here, and then here, and here, and here, and here, and so on. Okay. Yeah, WebEx makes it blurry. I'm sorry about that. I can tell you that the recordings are much clearer, much crisper. Okay, so now when we get to the end of this, we have the closest distance in closest, and we have the indices of the closest tuples in I and J, and we can just come down here and we'll steal this, and instead of printing I1 and I2, we can print L sub I1, right? We've changed it to use indices instead of the tuples, and L sub I2. Okay, and that should, barring any more cut and paste errors, of which I am fairly confident there are some, but we'll find out, this should actually work. All right, let's go back to Spider and let's see if this works. Tuple object is not callable. I don't want to call a tuple object. In line 2. Comma missing. I told you there was going to be an error. All right. And math is not defined. Why is math not? Oh, why is math not defined? Oh, because I didn't copy this part down. Let's try this again. Okay, there we go. So that's the other form of it. The first one just uses the elements of the tuple list directly, and the second one generates a list, a range of indices, and uses the range of indices. And by using the range of indices, we can get around calculating the symmetric parts where things are the same. Thank you, Dimitri. All right, let's see, we're at 455, 355, 356. So I guess we're pretty much done. If there are any quick questions, I'll try to field them. But other than that, we'll see you guys in a couple of hours. In that time, I have to get the last set of typos out, or the last set we're going to find out of the document, and get it all set up for you guys. So
Mins.
One quick question. Do we need the guard?
We won't mark you off for it. It's not a bad idea. You certainly won't lose points if you use it, but unless if we ask you to write a module with test code, then you would need the guard. If you're writing a main code, it's not strictly necessary.
All right, thank you.
Okay, you're welcome.
What if in the end I didn't complete one question? Would the code I write maybe count the score?
We'll grade it, as well as we can without it being complete. In general, if you demonstrate some competence in the material, you'll get something. But we can't necessarily know how much that will be until you look at it. Certainly, you'll get more if you get it all complete and right. But we will evaluate whatever you submit.
Okay, thank you.
Sure.
What would you do if you wanted to print, if you had a list with integers and a string, and you wanted to print the string first and then the integers afterward?
So something like, and you don't know where the string is?
No, I mean, like, you're given the list, but like, now format the list this way. Like, you have a list with strings and some integers.
And so like a tuple?
Well, not like a tuple.
No, I'm
like, yeah, like a string, comma, integer, comma, string,
gotcha, okay.
comma, integer.
Okay.
Yeah, like that, but like with more stuff. You know.
And it's a fixed. It's all like this.
Yeah.
Okay. So this is a good point. Good time for a more complicated range. So we can do. So we actually want to walk through this taking 2 elements at a time, right? So we can come through here and we can say 0, comma, length of L. So this gives us the boundaries we want to walk through, right? We want to start at 0. We want to walk to length of L. But what we want to do is we want to skip one every time. So we want to take it in groups of 2. So we'll do a range 0. Yeah.
So you'd have a nested loop for each thing you're trying to do.
Well, I mean, we could, but if we know that if we know that it's in this fixed format, we can just do it pretty simply. We can just do print. Right, we know that the distribution, so we can just do dot format.
Wait, Professor, what's printer?
A typo. It should be print. And then we can just do L sub counter and L sub counter plus 1. Okay, so we skip over every other one, but we capture it in the print statement. And that should, I think, actually work. Okay.
Yeah, but that wouldn't work for like if the string had like odd numbers or an odd number of indices.
If
you're skipping the 5, there's going to be a 6 indice. What if you just remove the 2, and then there would be the length of 5?
Sure. Then
so yeah, would that still work?
Well, it depends how you define
because it's
work.
Going to go
right.
Yeah,
it'll walk out of range. Sure. So
right.
Then we have to do something like this, right? We would have to do length of L minus 1, right? So this will stop 1 earlier. Will that do it? Or do we have to go minus 2? No, I think this will do it. So if it's odd, and that'll stop it one earlier. And then if you actually want that label out, you have to say if length of L modulo 2 something like that.
So 5 divided by 2 equals integer of 1.
That's modulo, so that's the remainder. Okay, so it's if the remainder when you divide by 2 is 1, that means it's odd. Then you just print out like the last one.
Well, if you divide it, it's 2.5. So wouldn't it be 5?
No.
And 1?
No, because remember what the modulo does, right? If you do an integer divide, right? 5 divided integer divided by 2 is 2, right? It's right.
Yes.
2 times 2 is 4. The remainder is 1.
Oh,
okay.
That makes sense.
Yeah. So 5.
So you're creating a separate statement to print the last value because the loop doesn't print the last value.
And that would only print out if it were an odd length list.
Well, I mean, like, do you have to like make a new statement to print the last part, or can you just do a one size fits all for it?
Actually, does that work? Well, I'm sorry, I'm not sure what you're asking.
Like,
there's no one.
My original question.
Yeah.
My original question was like, you take the original list with strings and integers placed in random scenarios, and print the strings first and then the integers.
Oh.
Is that how do you do that?
Okay, yeah, we can do that. That would it doesn't require 2 nested loops, but it does require 2 loops. So let's set up. We can make L as weird as we want then. Let's try that. Okay. So that requires that we use a type statement. So we can say for we don't even need a
right. If it's an integer, then you print it as an integer.
Well, so, yeah. So we can even do like for L and L, if type of L is equal to string print L. Right, and then we do the same thing with
But I mean, like, can you print it in a list? So like append a new list and then append the numbers. And then you can concatenate the list, I assume?
Yeah, or this append will do it just one at a time. This should take care of it, I think. Right?
Yeah. Okay, that makes sense.
Yeah. Okay.
But like theoretically, could you do 2 separate lists and then concatenate them? Like,
yeah, sure. You could do
list one plus list 2. List 2 has the integers. List 1 has the strings.
Yep, that would work too.
Oh, okay.
Okay.
Yeah.
All right. I'll catch you guys later. I still have some work to do.
All right. Thank you, Professor.
You're welcome. And by the way, you guys only are tortured for 90 minutes by this test. I'm tortured more on like the 12-hour range. So tests are bad for us too. We'll see you guys later. Have a good day.